Hey guys, how's it going? It's like week 15, 20 something of the quarantine. And this week we're going to be going over and reviewing how to understand topographic maps. So if you remember, topographic maps are the ones that look like a bunch of loops and circles all together. They don't look like the road maps that we're used to seeing. They look something like this. This is the one for Del Rio, and it's from the USGS website. So again, this is the Del Rio topographic map, but don't worry, yours is not going to be that complicated. This is what it looks like if you are actually a surveyor or somebody who needs these maps. Now, this is more of the kind of map that you're going to be seeing with the questions that you're going to need to understand and answer. It's a little bit more basic than the ones put out by the government. So this is going to be interesting because I downloaded a couple of whiteboard and screencasting apps on my iPad. So I am going to attempt to use those to show you how to answer questions and understand what topographic maps are for. So unlike maps that show you how to get places, because before we had the GPS things and cell phone apps, that's how we figured out how to go somewhere. We use real maps. The topographic maps don't have roads or things like that on there. Instead, they show the elevation. They show you the lay of the land, so to speak. Any hills, mountains, valleys, lakes, rivers, etc. That is what you will see on the topographic map. Instead, it will look similar to this, with the rings each being a different elevation. And the smaller they are, the higher up it is. These topographic maps are basically bird's eye views of the landscape surrounding you. So if you were to look straight down on a mountain or the city or whatever, you would kind of see what these maps look like. So going back to this picture, you can see from the topographic map that there are going to be two areas. And then if you look down at the 3D view, you see the two peaks. And the circles get smaller as they're going up. And the smaller they are, the higher and narrower they are. Okay, so let's start with the basics. These lines right here are called contour lines. The space in the middle, right here, these are called contour intervals. So the contour lines, that is where the elevation increases every time. So here, right on that line, it is 50 feet. Right here, where it says 200, on that line, that whole contour line is at 200 feet. And remember, when we say that, that means above sea level. So if it's at sea level, it's 0. If it has an elevation, it is that number above sea level. So the contour interval is the amount that it goes up between every line. And it will stay the same no matter how wide the line is or how narrow the space is. It's all going to be the same elevation difference. And to find that, if it doesn't give you the contour interval, you look at the numbers on there. So right here, we have 200, and here is 50. So we're going to do 200 minus 50, which gives us 150. Now we look at the spaces in between that 50 and 200. Here's 1 space, 2 space, 3 space. So we're going to take that 150 and divide by 3, which gives us the 50 as the contour interval. So that means every line goes up by 50 feet. So if it's 50 here, that means here is 0, then that 50, then 100, then 150. We have 200 there, so then 250. So the very top line is at 300. Now, lots of times you'll be asked questions such as, what is the change in elevation between X and Y? Now, to find that, first you have to find the elevation of each of those contour lines. We know the contour interval was 50 feet. And so if here it's 50, that means at point X, it's going to be at 100 feet. And then here it's 200, so point Y is going to be at 250. So to find the change in elevation, you are just subtracting 250 minus 100, and that is 150 feet between point X and point Y. Remember, you have to find the elevation of the contour line it is talking about. Don't use 50 or 200 because neither of those are on the line or the point that you need to be trying to figure out. So let's talk about the contour line spacing real fast. Remember how I said that it doesn't matter how close together or how far apart the lines are, the contour interval remains the same? That's because how close and how far apart the lines are from each other shows how steep or how gradual the slope of the hill or mountain is. Let me show you. I mentioned earlier that topographic maps are bird's eye view. I've said that a couple times. So if you are looking down on something that, like the pyramids, you're going to see a lot of that pyramid all the way down. You're going to see like a big square at the bottom, right? Whereas if you're in a helicopter and look straight down on a skyscraper, you're not going to see that much of it because it is so steep. That's the way it works for these maps. So the steeper or the more sharp the slope downward is, the closer the lines are going to be to each other. The more gradual or gentle the slope that the hill or mountain is, the further apart the lines are going to be so that you can see the whole thing. So lines close together, steep slope, lines far apart, gradual slope. So this brings us to the funny little V shapes that are on the left sides of our maps right around here. Now, what those are, that's showing us where there is a river or a stream. And what's happening is that the water flows downhill. Water doesn't normally flow uphill. So this little top, or the peak of the V, right there, is the top of the hill where the water starts. Then it's flowing downwards through these V's, like that. And then that ends up basically at the mouth of the river flowing into the ocean. So the water's going that direction. Here's our little stream going into the ocean. All this water here. Need a little bit of fish swimming out there, so you know that's the ocean. Make that one a shark. Make that one a shark too. All right, so remember, water starts at the peak of the V and flows towards the opening because it's flowing downhill. And one last thing is that sometimes you'll be asked, where would erosion or more weathering occur on a topographic map? And it'll give you one similar to the one shown below. To find that out, remember, once somewhere has already started being weathered or eroded, that's where it's most likely to keep going. So you're going to look at where there's already this anomaly where it's not perfectly round. And here we already know it's because of that water flowing down this way. But that is where more erosion and weathering would occur. It's not going to happen over on this other side where everything's just normal and there's no water happening. or bothering it, right? And that is the basics on topographic maps. If you have any other questions, leave it in the comments below and I'll get back to you. And y'all have a good week. I'll talk to you later.